Well, welcome, Andy. Thank you for joining us on our inaugural uh, episode of what are we calling ourselves? Two guys and imaging. Don't think we actually have a name yet, but really just some IT professionals that are trying to get together and bring on experts such as yourself. One because I'm selfish and I want to learn, but thought we could share some of those lessons with the interwebs, as it were, and kind of get the information out there. So thanks for joining us. And with me is Wayne. Wayne, do you want to
Yep, right here, guys.
All right, so there goes our introductions. Why don't you tell us where you're working and a little bit about what you're doing?
Andy, you're on mute, buddy.
I thought I was waiting for you, Wayne.
Okay. Well, you're our guest, so I wanted to give you first pass.
Yeah, Andy Domenico. I'm a data scientist. I work for Accenture, the IT consultancy firm. Don't let them hear me call that. They're more than IT. But primarily, I focus on. I, I like. I have a lot of different areas that I work in. Right now, I'm working a lot on vehicle routing and solving optimization problems under constraint. So uh, things that fall into the class of like NP hard or NP complete style problems, where you could you could maybe check a solution, which is an N problem, you can solve it in regular time, right? An NP problem, you might not be able to solve it, but you could check it. An NP hard, you might not even be able to check it, but you have to say like we've come to an acceptable or an agreeable solution. Um, it's a really fun area of like
There's not a lot of people that say things like fun and math in the same sentence, but
math, only with the pocket protector.
oh, okay. I'm just thrilled because you're a data scientist, and we like hear about people like you, and everyone talks about the machines taking over the world and AI and all of these things, and so it's just a big question mark for me. So I can't wait to learn from you.
It's all branding. Data science is just branding.
That's all. It's all marketing, right?
It's all marketing. It's just rebranded statistics.
No, but that's still really. But to Cal's point, that's really true, right? We hear so much about AI, machine learning. Then we hear about the data scientists, and then that's quite a dynamic field. So we are excited that you're doing the call because we really would like to learn more about how you take that ideology and you put that into a best practice. It's not just solve business problems, but also how does that equate down to a monetary outcome for your customer? How you help them, I guess, harvest that data to commercialize, to monetize it.
Yeah, and I'll take a step back and say I kind of give data science a bit of a bad name by calling it just statistics. It is like at its most primal level, right? But there's a lot more to it as well, and an important distinction that I'll make up front, and even more important, I have to give the little disclaimer: my opinions are my own and not necessarily those of my employer, Accenture. But the different machine learning and AI are heavily related fields, but different, right? The AI is really, when I think about it, is the reasoning part of it, and the machine learning is the mechanics of how the machine reasons, right? And that's really where the heavy maths come in. So, can the machine read in inputs, perform some kind of calculation on it, determine if this is good or not, and then do it again, check and validate and keep going in a long cycle. And the results of those learnings and how the machine improves its performance over time is what's ultimately kind of represented as AI. So when you see like an image processing or like a photo processing app, right? So when you put something on Facebook, right, it's running that photo through their image recognition database. It's picking, based on the facial characteristics of what's in here, I think this is probably Kyle Henson, and it suggests Kyle for you to tag, right? Well, it's doing that because it's taking the image in and breaking it down into all of its pixels and mapping, the distance between the tip of the nose and the center of the eye and the tip of the ear and other landmarks adjusting for like the rotation of the face. All that's being done by the machine. The trick is the first time it ever sees an image, it's really slow. Like it's got to query its whole data set, right? And then it can start learning search techniques to get better at it, right? And those search techniques speed up the time and reduce the amount of compute that you need. So you can get to these results faster and more accurately. Now, image recognition has had huge problems with bias, right? Where there are a lot of documented cases where it works great on white males, but doesn't work well on African American females, right? I could probably point you to some case studies. So never let a data scientist tell you, their algorithm is great under all circumstances. Oftentimes, it's a work of art that's made for one thing.
Yeah.
And is heavily tuned by the data scientist to produce a particular result. You start from a common platform of, you could use, a support vector machine or a random forest of decision trees. But oftentimes, the way you tune that model will give you different results with the same data. Knowing how to do that tuning, how to do those different search characteristics that's the data scientist's job.
I don't quite understand that you tune the same data, you tune it, and you get a different result. Can you give me a simple example?
Yeah, it's kind of like torturing a person. You can torture a number, and sooner or later it'll tell you anything you want to know.
Okay.
But let's say I have a set of data that predicts churn in a company's subscriber base, right?
Okay.
So you're trying to predict if this person is gonna leave your company. Well, I could try a support vector machine to discriminate between churners and non-churners, and I might say, based on this particular algorithm, it believes that Kyle is going to churn and Wayne is not. So Wayne's going to stay subscribed for another year. But if I take a random forest, it might say, well, both Wayne and Kyle are going to stay, but Andy's going to churn. Same population, same data set, but it may come to slightly different conclusions for slightly different reasons because of the way that that it's treating the data. It
Okay.
also depends on how long do you let the model run for? How many, what parameters do you set? Because you could set your model to search very broadly, but not deeply. So, you might say just take a bunch of variables into consideration, but only probe one or two levels down, so you get a broad general picture.
Mm-hmm.
Or you could say, I want you to focus on just one or two variables, and I want you to go really, really deep on those one or two. The trade-off is, in both of those scenarios, you miss something. So let's say, what makes Kyle and Wayne different from Andy exists at level 3. Well, if I only run a model one or two levels deep, then I miss that variable.
Yeah.
And something else becomes more important. But if I run it like super deep, and what makes us different is up at the surface level, then I miss that variable. So it's how you slice the data within your model. You can get different results just based, and ultimately, if you run a model a bunch of times, one of the great tricks is randomizing some of your data. So like when I'm running a fleet routing algorithm, I say, well, okay, Andy starts from point A, and Kyle starts from point B, and Wayne starts from point C. Take Andy to point D, right? Well, now neither Kyle nor Wayne could get to point D because Andy's occupying it.
Mm-hmm.
Well, in my next simulation, I'm going to say put Kyle on point D and put Wayne on point A. Depending on how many times I run the simulation, I'm going to come up with a different end product, right? Just based on, did I tell the machine to randomize the first start, or did I tell it to go, in a strict order? Did I tell it, what did I tell the machine to do? Because in spite of AI, machines are really dumb. They really just do what we tell them to do.
Yeah, I
And
mean, they can only act on the data you provide, right? So it's a quality, not just a quantity data. And also, it sounds like it's really a customized, tailored solution.
a lot of AI is like that. There's a big distinction in the AI world between AGI and AI, and narrow AI and broad AI. Right? Narrow AI is something that's really suited to a task, and you build a custom solution for that task. So, image recognition software, great at recognizing this is a cat, this is not a cat. Can it drive a car? No, it can't. Like this piece of software can't do that. Even self-driving car software, it could drive a car, but it couldn't answer my email for me, right?
Right.
Whereas a chatbot can maybe do some of that. So a lot of AI that's in the marketplace today is really narrow AI that's built to a custom end for a business
Mhm.
or for a particular thing. AGI is what everyone kind of like either longs for or fears, right? That's
Right.
the machine is now capable of recursive self-improvement, and once it hits that point, it's just going to keep getting better and better, faster and faster exponentially, and that's when it overtakes humans, and the machine is now your overlord, or your benevolent overlord, depending on how you want to how you look at
On which
Yeah,
author?
it depends on which Hollywood movie you're watching, right?
it. Yeah, exactly.
Yeah. No,
Um,
but that's really cool though. But you are working with some clean data, and it sounds like that because of that you are working, as a consultant with Accenture, for you helping these companies, not just with fleet management but also with resources to make sure the fleet stays efficient. Correct?
yeah, yeah. Fleets are wonderful, complicated things. You know, how's your acceleration and deceleration?
Okay.
How's your engine idle time? What's that doing to your battery life? How many jump starts and tows do you incur? Because if you're out trying to make a delivery and your vehicle breaks down, well, you just missed all your deliveries for the day. Bad customer experience. Plus, you got to incur the cost of a tow. So there's all kinds of stuff that you can take from IoT sensors, feed in to predictive models. But my model that predicts breakdowns is very different from my model that says I should send Wayne on the route, over on the west side of town to make these deliveries versus sending Kyle, right? Because of the difference in start points or the load carrying capacity of your truck or something like that.
That's fascinating. If you don't mind me, Carl, one more quick question here I want to follow up with. When think about this, right? These companies, how do they measure this? To where are they measuring success based on customer sat, or is it a combination also of helping lower costs, efficiencies, etc.? Right? I'm like, at the end of the day, this takes a lot of work, and then you have to ask yourself, how? Colin, we were talking about this earlier. How they measure for success, and then how do you position yourself to continue to be that high value asset?
So, how are they measuring it, or how should they be measuring it?
I'll default to you to answer that.
Yeah, you're right. A lot of it's just straight cost. Can we automate a task that previously had to be done by a human, right? Dispatching trucks. My algorithm can probably get you a more efficient route than a human could, right? In math, it's what's called the traveling salesman problem. If you have a salesperson in Chicago and he needs to go to Vegas, Seattle, Dallas, Houston, Austin, Atlanta, whatever, what is the fastest route to get him through there? And with one person and 7 stops, you can work it out with a pencil and paper. It's like 36 possible combinations.
Is that all?
Yeah.
That's
36
easy.
possible routes. You could do a pencil paper. You get 2 salesmen, and now all of a sudden, like, you're up to 40 or 50 possible routes because some of them could go to some cities. And you start getting into 10 people and 100 cities. It's something like 3.459 times 10 to the 15th power.
Good grief.
You hit what combinatorial explosion. There's so many possible routes that no human can map them all, right? And same, you you even actually using machines, there are more possible routes than there are atoms in the universe. So I could
Wow.
take all the compute cycle I have and run it for the lifespan of the universe. I'd probably never be able to prove that this is actually the optimal route. But if you learn shortcuts, you can figure those things out. But back to the question, really, of a lot of its value, it's, can I automate a job that previously had to be done by a human? So cold-hearted, but I no longer have to pay that human. They can do other things,
Mm-hmm.
right? Am I reducing, in the case of fleet, like, am I reducing fuel expenditures? Am I reducing my my miles per dispatch, right? So I'm finding shorter, tighter routes so that one truck can handle more deliveries, or or more jobs. One driver can handle more jobs, and that way, if I have one driver handling more jobs than he used to handle, that difference in efficiency lets me either take more customer orders, or surplus another driver somewhere else. So those efficiency measures are actually usually fairly well defined. The way we should be measuring it also is customer satisfaction, right? And long-term outcome from the customer. Um, like in health studies, I see a lot of things where, oh, hey, we got 3% better at at performing the surgery quickly. What is the long-term outcome of 5% rise in post-surgical infections? I don't know. We didn't do the study long enough, right? That's a little bit of levity, but you can't just take one number, boil it down, and say there's your value. You've got to look at long term. How is this affecting and changing your business? And is it a good or bad thing on balance? Because trucks are simple, right?
Right.
Like, compared to healthcare, like, trucks, I can probably say, like, yeah, we cut a bunch of mileage out of your fleet. And that's overall a good thing. Um, in healthcare, it's really like, well, yeah, it looks good on the surface, but what's the long-term impact on that person, right? Like, what's the long-term impact on their health, that one individual patient, versus the $35,000 truck that you're going to buy a new one sooner or later anyway.
I mean, that you bring up a great question, because I was kind of wondering, like, how do you decide what is good for AI and what is not? So how do you know when someone comes to you as a data scientist and says, I want to, I don't know, answer my emails. I want AI to answer 90% of my. How do you how do you tell somebody, or how do you even know whether something is a good candidate for AI or not? Because right now it seems like everything is going to be run by the machines.
Yeah. Um, I wish somebody would answer 90% of my emails here.
Right? It sounds good, doesn't it?
Sounds good.
Hey, you invent it, and we'll do something here.
No, there are just, yeah, there are so many things that machines are good at and things that machines suck at. And it's important to know those. Like, um, machines are very good at chatbots, right? You've probably interacted with a few. Okay, I shouldn't say very good, because some of them are truly dismal experiences with chatbots. You're like, I don't know, just get me to a human, right? Same
Right.
experience you had with IVRs, right? Where you say operator just over and over again.
Right.
Right? But some of them, I don't know, my bank, I like their IVR. It's fine. Like, I punch my number in and it says, you want to check your balance, press one, transfer funds, press two, okay, how
Mm-hmm.
much, blah, blah, blah. Simple, easy, done, right? Guess what? A human used to have to do that job, right? They were
Right.
called bank tellers. So when you think about, like, what things are kind of candidates, there are so many things that have been automated anyway through, like, ATMs, through IVRs, that are now being kind of caught up in artificial intelligence, because it's the completely online experience, instead of even over the phone, or visiting an ATM location. and you have to run it at web speed, right? So you have to have a decision-making agent that can understand what you're talking about. Some of them are good and some of them are bad. Answering my email is probably a really bad candidate for AI. Hate to say it, dude, that's not coming because the AI it can effectively emulate a customer service representative because they're really governed in the things that they can do, right? Like they follow scripts. Most of them do.
Gotcha.
Speaking as a former customer service agent myself, most of the time you follow the script. You press the buttons in the order, but you've got to be able to think a little bit outside the box when you've got a customer, and maybe they want more than one thing. But machines are pretty good at following process. But answering my email, there's no process to it. It's all unstructured. It's completely context driven. And especially, how many emails have you got that said, hey, following up to our call? Well, if your email responder bot wasn't on the call with you, then it doesn't know the context of that email. So things like that are highly dependent on personal interaction, bad candidates for AI. Things that things that look like they can be solved really mathematically, like self-driving car or truck routing or things like that, good candidates, because you just got fundamental pieces of data there, right? That you can manipulate and you can clean up. Handwriting analysis, yeah, actually pretty good candidate. Like train it on billions of samples of handwriting, and sooner or later it's going to get it right. But then you have people with sloppy handwriting that just falls out. So you have to look at kind of each use case. But I'd say anything that relies on structured, semi-structured, or data that could be structured given an appropriate schema is really good for AI.
Well, let me pause you there for a minute there, Andy. You brought up a really valuable point here to the healthcare guys. That seems to be where where we are in the world today is structured data. Now I'll let Kyle talk more about that, but I mean, this may not be the appropriate call for it, but you brought up something I think that really resonates with Kyle, his background, and what he's doing over there at Change.
I knew I was like dangling red meat in front of him.
I know.
Well, I mean, it's a really valid point, and that's just where a lot of the investment and resources are going right now. Do I stand corrected, Kyle? What do you think about that?
No, I mean that's the real question. Is we're looking at image data, and so one could argue that looking at an X-ray is fairly contained. It's an image. You're looking for pattern recognition within the image, and so there's that arguably would be a good candidate, I think. And there was certainly a lot of early AI research, a lot of early AI publishing that predicted the demise of radiology as a specialty. Has not come to fruition yet, and love to hear your thoughts on that, because I can see both structured, unstructured, and contextual data all wrapped together depending on the case.
Yeah, and the keyword there is yet, but we're all eventually looking at just fundamental shifts in employment and life from this. But radiology, when you're looking at it, you're looking at an image, right? And the machine is trying to pick something out from the image. It is pretty good at picking out stuff. But there was a really great study I read recently where it could pick out a tumor like 99.9% of the time on the lung in a radiology image, far better than any human radiologist could. And they tried it, and in real life, it was no better than random coin tossing.
Wow.
What gives? This thing did so great in the lab. What they found was the images they had trained it with, all of the examples that were positive for a tumor, they all had a little ruler in them to show scale. And what the machine learned was, if it's got a ruler in it, it's a tumor, because they're measuring the size of the tumor. So all of their true examples had this one false thing. And this took, it was a long-term study to try and train this machine to do it. And ultimately it ended up being, flawed, because their data was not what they thought it was. They thought that this image of the lung that is clear, right, never ended up having that little ruler in it because they weren't measuring a tumor. And every image that was not clear basically had a tumor, and had the thing. So the quality of data is paramount, right? And understanding that data quality is paramount. But reading, actually just reading the image and being able to determine tumor or not tumor is strictly dependent on the quality of your training data set. And was it good? Was it what you thought it was? Did you make assumptions about it? And that's a huge gap, because in healthcare, again, if I make assumptions or I take certain shortcuts, then or my data is not really what I think it is, it can have an adverse effect on human life. And I'm all for training the machines better, but at the same time, you hear stories like this, and that's anecdote, and the plural of anecdote is not data, right? There's been tremendous work done in this field, but it still is a little difficult, I think, for humans to put our faith in complete automation. I think the path we're on is really automation with human supervision for a long time. Mm-hmm. And then we'll get to automation with less human supervision, or automation, and then complete automation, but human supervision in the most complex cases.
Okay.
So there's a ramp. I don't think there will ever be a hard cutoff in imaging or radiology where you just don't need a radiologist anymore. But you probably need, as the years go by, you'll need less of them, and the ones that you do need will be the most highly skilled. Because the most images are negative for what you're looking for. Be it a tumor or ulcer, whatever else you're looking for.
Sure.
Most images are negative. Well,
yeah.
Do I need a human to look at all those negatives? I mean, maybe I could have a machine that gets through all those a lot faster and says, these ones are my potential positives, and I kick those to a human, right? Because there's something that torqued the machine about it. But 1,000 images done by a machine for a cost of pennies, and it kicks the 100 or so that need review to a highly skilled human, and the machine can tell that highly skilled human, I want you to look at this, this area, right? This is what tweaked me, and I can't make a decision on this. I want humans to look at it. But as they make decisions on it, they start feeding that data back into the machine, and it becomes better.
I like that example a lot.
Yeah.
That's something that we can all relate to, right?
Yeah.
Very cool.
Now, how does the machine learn? Do you have to tell if you say you've got your chest x-ray or this chest, and you want to teach it a tumor, do you have to tell it, just show it a bunch of examples and say tumor yes, tumor no? Or do you have to tell it, go look here, this is what a tumor, how does one train machine learning?
That's a technique called supervised learning. So what you do is you have your images, and they're tagged tumor yes, tumor no, right? And then they're fed through the observation space. And you have your training set, and then you have a holdout, like test set. So 100% of your data, maybe you train on 70 or 80% of it, and you hold out 20, 30% that the machine will not see. And you just run those same images through, and you say, predict whether it is a tumor or not on the training set, right? And the machine says, okay, I see, I've got all these pixels in this area, right? Because what it does, it breaks the image down into a graph with vectors, and it's got every pixel is represented mathematically. So it's not really actually looking at the image; it's looking at like a mathematical representation of the image in a graph format. And it says, given the density of the pixels in this one area, I predict clear, or I predict tumor. And what it does, it gets to see the answer, see if it was right or not, and then run it again. and then run it again and again and again. And sooner and after many iterations of this, it comes out on the other side and says, I now have like a trained model,
Mhm.
right? I've learned how to predict this with high degree of confidence. Then you expose it to your holdout set, right? And then say, okay, here are pictures you've never seen before. They're not the same pictures recycled or in different order, totally new. And then your model tries to train on those or tries to predict those. And then you get to see the answers and the model doesn't get to see it. And that's really where you're finding out your precision, your accuracy, where where your model might have weak spots, because it may be very good at spotting tumors in adolescents, but it might have a harder time with with different demographics, older people, seniors, right? Because maybe it trained and had a very heavy proportion of adolescents in the training set, so important to randomize too. But that's really what it does. It's taking labeled data, trying and running on running on that set for a long time, and then it has data without labels or without labels that are visible to it, and then you try and test against that and see where it shakes out. And this is where there's a lot of like art to data
Right.
science. It's not a science. Really.
Data science isn't a science.
Data science isn't science.
I love it. That's going to be the caption for today's.
Right. Right. Let's debunk it.
Yeah.
No,
I
I mean,
told you I give data science a bad name.
that's crazy. I mean, that's it's interesting how you would train it, and then just I've read a lot of different articles, and so I have a very poor understanding of it. But how if you use the same images over and over and over, how does it how does it not just memorize what it's looking at? How does it learn?
Yeah. So it is kind of memorizing the training set, but it's trying a different thing each time, right? So when it's seen the training set once, and it sees, okay, all of the ones that are positive have this characteristic, right? They all or most of them have, this little shaded area down here, right? So it sees it and it says, okay, now I can make my predictions. And what you can do is then fold your data or split it up and bucketize it and try again and try it again, things like that. It's the same kind of thing with with a different technique called unsupervised learning, which is how you train like game playing machines like Go and chess. You just let it play a bunch of games, right? You let it run over and over and over again. And sooner or later, it learns that you know first move is best is always like move your knight to control center board, right? Stuff like that. So it learns in image recognition. It's learning. Yeah, this cluster down here, most of the time, this means a positive case with these exceptions, and then it starts learning the exceptions. So if the if this piece of like if the metadata says that it was taken in February, all the ones that were taken in February that have this shading, they're not they're not negative. It could be a spurious correlation, but I'm just making up an example.
Right.
So so once it's done on a training set and it's learned the rules of the training set, that's when you got to test on held out data, and that's your true test, right? The example I gave you with the ruler, right? I think they did even test on held out data and it looked good, but then really real world, it didn't. The samples didn't have the thing. So yeah, you have to take data that's labeled, try it, learn from it, try it on a test set of data that the machine has never seen,
Right.
and then you feel confident enough that maybe you go to the real world to a limited set. I guess the same way the FDA does drug trials, right? They try a lot of different formulations, eliminate the ones that don't seem to be working, come to the ones that do work. Maybe then they try it out on animal trials. And then after they've met certain milestones, then they go to the FDA and get permission for humans. The trouble with AI is we don't have such a rigorous set of standards as FDA drug trials do.
Mm-hmm.
I know guys who can chug a couple of Red Bulls, write an AI algorithm, and turn it loose on the world tomorrow. Right? Okay. I guess, if your business model calls for that, like you've got to be really fast to adapt, then cool. But
so
it should be AI and healthcare should be treated to the same standard as pharmaceuticals.
Mm-hmm.
I guess is kind of my point.
Okay. That makes sense.
You're risking you are literally taking risks with people's lives at
Absolutely.
We need to treat that with the same degree of sanctity and the same degree of supervision that the drug industry is held to.
So do you think that we started talking about what is AI good at and what is AI not good at, and then we kind of pivoted and we're talking about images and basically the diagnosis of images.
Yeah, that went on a tangent.
It sure did. I mean, well, that's because we're kind of imaging people, but that's my love language. But I guess the question is I see so many other places where one could use AI within a medical setting, and I wonder if, I mean, I guess this is a leading question, but I wonder if diagnosing images is the best use. Is that where we can get the most money, the most accuracy, the best improvement, or are there other places that might be better use? That, I mean, kind of back to the what's a good use case for AI?
Yeah. In the health setting, I think imaging has been really well studied, right? It's a well studied field. There are kind of clear standards in pharmaceutical research, right? There are cases now where AI is being used to eliminate candidates with poor predicted scores. So if you have a candidate compound that you're basically making predictions about will this compound succeed, and maybe it's gone through one round of tests, you can start eliminating compounds that really don't seem like they're going to have an eventual payoff a lot earlier in the process, and you save a lot of R&D money that way.
Right.
So that's actually a fantastic area for AI is pharmaceutical research. Obviously not in the direct care, but it's upstream of that.
Right.
And has it downstream. Another upstream, reducing fraud and abuse in our healthcare system. Right. There's always fraud. There's always abuse in the healthcare system, but AI can make that a lot easier to catch, and catch it when it's small, rather than waiting until it's a really big scam and has already cost insurance companies and providers millions of dollars. AI can identify suspicious patterns. Pattern recognition is what AI is good at, and don't let it go too far. Right? Humans are hardwired to see patterns in everything, and AI can do the exact same thing, and can say, well, I see everybody who comes to this hospital is probably committing fraud because they all have they all live in the zip code, and the zip code is a high fraud zip code. No, right? Dumb machine, right? Bad program.
I was gonna say to your question, Kyle. So I think by the way, I think that's a really appropriate question. And based on Andy's response, I think the areas I think where AI could be most impactful right now are like in actual how to reduce billing errors, how to predict attacks like ransomware attacks or breaches of security, when it comes to accessing whatever sensitive information it is, because as we all know, these hackers come in, if you want to use the word loosely, hackers, right? They come in and they will somehow breach a firewall and access information and hold a hospital basically hostage, right? And they can go in and they can lock down databases. They could intervene and actually completely disrupt the EMR, whatever it may be. So I think there's a lot of use cases for AI on the business side or on the operations side, because to your point on the imaging, there's so many important variables where it takes expertise. It's not just so. Even when you have, I mean, Kyle put it perfectly, right? You have machine learning, you have pattern recognition, you have AI, you have contextual data, structured data. I mean, now we're talking, to so many different experts to come in to help decipher what that is. But I think on some things that are more cut and dry, right, like zeros and ones and along those things, whether it's financial or it's security based, I think that's where AI could probably have some of the most impactful outcomes. Just based on what I'm hearing on you, Andy. I mean,
I
just
think so, because that's that's a you're right way to in those IT systems. There's a lot of areas for improvement, kind of everywhere. It's not unique to healthcare either, right? Ransomware
yeah,
attacks can hit anything, um, and identifying and detecting the ransomware before it gets installed, holding that attack at the border, like keeping it outside the firewall,
mm-hmm.
huge advantage, right? Because once it's in, you're screwed anyway. But yeah, billing errors, another big one. Fun story. I have twin daughters, and the day they were born, or the day after, rather, I called up the insurance company and put them on the policy, and a week later we got two bills, one for each of them, one for like the $200 copay, and one for like $20,000. I was like, wait, what? And they're like, yes, she's not on the policy. And I said, I called you and put her on the policy. And they look and they're like, oh, well, we dropped her because she was a duplicate. They're two, both female. It's like they thought it was the same record because they both have the same birthday. Have you never experienced twins before? I'm not going to say the name of the insurance company, but if I said it, everyone in the world would know who this is.
That's a great example, though. I mean,
It
there
is.
you go, right? And people will sometimes they take the information at face value. Like, well, hey, the machine can't be wrong.
Yeah, they just trusted that the machine thought it was a duplicate and they threw it out because same last name, same birthday, same hospital, must be a duplicate record.
But you know what? Deduping records is also important. So that's the classic problem. The false positive or the false negative. Which is worse?
Exactly. Well, I mean, I didn't end up paying that
Oh, well, yeah.
money.
I think the $20,000 bill is pretty bad. So
Yeah.
That was pretty rough. Um, but yeah, billing errors. I mean, in healthcare, I think a lot of people are so confused by their insurance, and they're so confused by what's the difference between co-insurance, copay, and out-of-pocket deductible and lifetime max. I just said all of these words have meaning. I don't know what any of them are. I've just heard them often enough, right? People get so confused by their insurance that confusion and that lack of trust gets bound up in the whole healthcare system, and it's hard enough to trust your insurance company and your healthcare system. If we start layering more things in there, right? You've got to think about what's it doing to the patient and their trust and their willingness to come to your hospital or your doctor's office or to use your services. Automation can, and AI can maybe streamline a lot of that and reduce the need for these. I think Scott Adams, the creator of Dilbert, said it best. The insurance companies have created, instead of a monopoly, a confuseopoly, where you're too confused to be able to pick the right choice. Because they just throw it. Airlines are guilty of this too, by the way. Like what's in my frequent flyer program?
Oh, geez.
According to you, I'm an admiral of the skies, but I still sit in a middle seat in coach. But how can AI streamline insurance offerings? How can AI streamline the intake process in a hospital or a doctor's office by understanding what's your personalized health record? There's tons of things there that can be done to reduce friction and improve the flow of patients through the hospital, even down to simple floor plan designing, right?
Right.
You guys have been in hospitals. They're rabbit
Yeah.
warren.
Well, I got to tell you what, Andy, you're a keeper. I mean, there's so many ways we could take this conversation, right? I mean, healthcare is just one example. Transportation, business, right? Um, man, I wish you nothing but prosperity and long health because you're going to have so many opportunities to go out there and leverage what you're learning, right? I really agree with what you're talking to, and that is about taking specific segments and hopefully using AI to create more efficiency and some mastery to create consumer confidence and eliminate errors and not sit there and confuse people and then create negative emotions, right?
Yeah.
Part of the customer sat experience. Yeah, really, I mean, really great talking points. Oh my gosh, be here all night. It's a good thing though.
Oh, I
Sounds
know.
like you're having fun.
I am having fun, man. I'm sitting back chilling. I have a hard stop in about 10 minutes, but I you know I could talk about this for a while. The only other thing I think that like kind of we didn't talk about in AI is it's real easy um, for we kind of tangentially touched on. It's real easy for AI to like go and do the one thing that it's been told to do and knows how to do it really well. And that's what I think everyone needs to be super careful about, because it'll do it, right?
Yeah.
And that's I hate the Hollywood disaster movies. I mean, I love watching Terminator, but I hate like the concept, right? I don't like that of the evil artificial AI that is going to kill us. I think more likely it's sort of humans gave AI really bad instructions and didn't think about the consequences of their actions, and then AI kills us, right? It's
I,
like imagine if you create the godlike AI, and and it's recursively self-improving, and it's hit the point of the singularity, and it's it controls the economy of the planet now, and you've programmed it with a goal, and then you said that goal is maximize human happiness, and the machine figures out that human happiness is really a function of endorphin and dopamine. So it basically just hooks everyone on the planet up to a morphine drip. Human happiness has been achieved, and we all die, right?
I'm,
But
I'm just waiting for you to bring up the 3 laws of robotics. Like, you were like right there.
we need those. Like sci-fi junkies unite, Asimov fans.
I mean, AI is essentially taking what humans want, but we're moving some of the emotion out of it, right?
Yeah. And if you do a bad job of really explicitly stating those goals, then you run the risk of AI actually giving you what you want. Like all the kids' stories about the genie. They make the first wish, they make the second wish, and the third wish is always like, please make my first 2 wishes just go away.
Yeah.
You don't get that chance with AI. It's going to do what it wants to do at blindingly fast speed. There was a case, I think, where one of the big financial firms in New York like turned on their AI engine and lost something like $400 million in a single day.
Oh my goodness.
Because it was doing what they told it to do.
Yeah.
And I think it was like 7 of their 8 servers were doing what it was supposed to do, and 1 server wasn't. And that 1 server kept like countermanding orders. Other cases have occurred where traders have been trusting their AI algorithm, and it's gone out and made a massive market position in something that was just about to tank. And the humans on there are no humans on Wall Street anymore, really, but human traders programmed other algorithms against it and learned like this is a dumb router, like this is a dumb algorithm, and we're going to deliberately trade against it. And we only want to trade against the dumb one, and then the dumb one ends up costing its creators a whole bunch of money, right? It's kind of like a war of robots, and the slowest robot loses. So never have slow down robots. Have really smart, fast robots, but understand someone else is probably going to build a smarter, faster one. In healthcare, right? If you turn over health decisions to an AI whose reasoning you don't understand, then you may get really bad decisions and really bad outcomes times. That's why, like the
Yeah.
radiology example, if we really do need human supervision, you can allow AI to handle a lot of stuff, and over time it will get better and better. But what's important is the humans have to understand it, know it, and not just blindly put their trust in it because AI, right?
Yeah.
That's one of the things I like drives me bonkers. Like, oh, the AI said so. Really? Did you talk to it? Did you did you understand what it was saying? those are not good reasons.
I mean, you bring up a great question. If we had like another 2 hours, I would love to really dig into, because you alluded to it very early, which is, well, we taught the AI to look for a ruler, and then you just said it two more times about, well, how did it make its decision? And that's probably a whole different discussion into understanding retroactively how it decided something, which I would love to get into it, at some point, but not in the 6 minutes.
Explainability in AI it's hard. It's really hard. It's one of the big problems in the field, and I'll I'll kind of close with this. Um, just because the machine makes a different decision than you do doesn't mean it's crazy. It may just be unintuitive, right? The really classic example is AlphaGo. When it was playing against the World Go champion at the time, it made a move that move 37 in the game, and it's called a shoulder hit, where it placed a stone on the board, but it placed it on like the fifth row, and everyone was like, "Oh my God, this is such a bad move. It's a horrible move. Why is it doing this? It's such a terrible move. Like centuries of human experience have told us this is a bad move." But that stone there ultimately led to a chain of events that caused AlphaGo to like capture 3/4 of the board against Lee Sedol, the reigning champion. Right? It was a totally counterintuitive thing. No one could figure it out, but AlphaGo could. So it's not always that those decisions are bad, right? What I challenge everyone to think about it. Think about it a lot. Just because the decision is not intuitive to you doesn't mean it's bad. It also doesn't mean it's good either. Humans have to really up our game on this stuff. There are huge shortages in the data science world of people coming out from college, grad school, going into the field. There's huge shortages, and they need the critical thinking skills to say, I don't just blindly trust my model, right? And I think in healthcare, there's a lot of that critical thinking. People don't just blindly trust anything put in front of them when it could affect patient health and well-being, right? Not so in other industries. They'll just take whatever's fastest, best, and cheapest. But in healthcare, there's a lot of that may slow down progress in healthcare, because I think physicians and healthcare professionals are going to challenge and question AI, and that's healthy. I think that's good. But AI practitioners hate being questioned. Like it, just accept what I'm telling you is true. But data scientists should be challenged on anything.
Gotcha.
They should be challenged on their findings, even though explainability in AI is very, very hard. If you're going to trust the life and health of your patients to them, they should be held to the same standards as doctors and pharmaceutical researchers, right? You want the responsibility, do the hard work of figuring out how your own algorithms work. So I'll get off my soapbox. You're right. We can.
No, it's great. It's great stuff. Thank you.
Well, I know. Well, I think you said you've got a hard stop. I think, thank you so much for spending some time with us. I love it. That was great. Like I could seriously go on for hours. This is really exciting
when
stuff.
Gets done, we'll do this over lunch.
Yeah, I know. And Andy, very nice to meet you. By the way, I'm based out here in Dallas with Kyle. I'm with a company called Pure Storage, and I'm an AE out here for healthcare.
I know Pure Storage.
Awesome. All right, man.
I've used your stuff, man. It's
cool. All right. See, that's going to be another talking point next time.
That's right.
Because we have an investment with NVIDIA for the AI use case. And so I think that'd be something that we could put our heads on and think about. How can we talk about that?
High speed caching, lots of use cases around near real time data.
Very cool.
Yeah.
Cool. All right, guys.
Thanks so much for your time. Appreciate it.
Catch you later. All right.
All right.
Yeah,
Take
man,
care.
Thank you very much, Andy.
Alrighty.
Take care.
Bye now.
Kyle, good stuff, man.
That was
Well
fun.
done.
I enjoyed
That
it.
was very fun. Dude, we blew an hour just like that.
I know.
That's great. That's great. So thank you for putting this together. I will, listen when time allows. I'll let you draft some of those ideas